diseases, disorders in human beings. Okay, so it will initially start as a very small nodule, okay, very micro nodule. Then it will start slowly becoming big. Okay. Then what it will do? It will catch up some blood vessels. It wants some what we say. It is also cells, right? For its sustainability, it will suck the blood of the neighboring blood vessels and it will start growing for that. And why innovation is important in this field? We will see that. We know cancer nodules, they are very small. The earlier you detect it is better. Okay, the chances of saving the patient will be very high. Okay, so and detecting that cancer nodule at a very early stage is always challenging. Innovation is a must. Okay. There is a without innovation nothing is possible in medical imaging. Okay. So already in advanced countries like America, etc., every year, okay, patients are advised voluntarily to go into cancer screening. Okay, what they do? Every person who wants to voluntarily subject himself for cancer screening, he will be cancer screened. Means CT scan of his whole body will be taken. Okay, using a very low dose CT scan. Then they will do the radiologist will go through all the CT slices and they will check whether he has got any cancer nodule in him or not. And this process, it is a very, very tedious process, and for every person, okay, around thousands of slices will be there. Where a small cancer nodule is there, if the person must detect, if the radiologist must detect, he must go through every slice. Okay, I will show you what is a slice here. Okay, so every slice he must go through to give decision about one patient. Almost it will take 1.5 days for that radiologist. Okay, just imagine millions of people are there. Okay, very few radiologists are there to go through every slice and to tell whether the cancer nodule is present or not. Okay, it is a very tedious job. So here comes the need of innovation. Okay, we have got technology also now, okay, which will within 20 or 30 minutes at the most. Okay, it will scan through the entire body and it will tell exactly where the nodule is there. So of course some accuracy, all that. Okay, it will be there. So even now, detecting whether a nodule is cancerous or non-cancerous, okay, even for an expert radiologist, it is difficult to tell whether the nodule is cancerous or not. That implies for image processing techniques have still not reached perfection. There is still need for innovation. Okay. Yes, we will with this we will proceed with the talk. So this is the tool, okay, 3D slicer. It is every year now and then it is getting innovative. Okay, the new features will come. What other features are there? Okay, we need all of them. Okay. So it is easily installable. Within 3 minutes it will get installed on the door. Just Google 3D slicer on your system, very nice. Okay. And it will take you to the page where you can download it. And in 3 minutes it will be installed and you can use it like this. So I will first show you what is a CT scan, CT scan volume. I will explain you what is there in it. So I already have got some CT scan volumes in my system. I am taking that. I hope this is the right. So I am uploading some files here. So here is one file that I have got. So this is the CT scan. So can you identify what it is? What is on the left hand side? What is this? What is this? Did you identify what it is? It is the CT scan of chest from here to here. Okay, the lungs end somewhere here, right? So from here to here it is taken. Slices have been done in this direction also. Okay, cutting it like this. So if I cut one small slice and if it will be like sheet, right? And if I show it to you, it will be this. Okay. I cut my body like this, okay, from here to here, and around 600 slices from here to here, cancer nodules will be very small, right? Correct. So if you want to go through it and see from here to here where the nodule is there, you must go through every slice. Okay. So I will show you how to go through each slice. Okay. I will enlarge the red. I will enlarge the left hand side screen only. This screen I will enlarge. You can see this. Okay. So this is one of the slices. If you want to, you can move to here you can see here. This is zeroth slice. Okay. Where am I now? I am near this abdomen part of the lung. Okay. So now what I will do, I will start going up, slowly up. You can see that, right? These are all different slices. Okay. So now here, somewhere here, lungs slowly start. Okay, this darker area you can see here. Okay, this here. As we keep going up, okay, slowly you can see a lung appearing. You can see this dark area, that is lung area. You can see here. Okay, it will start coming up. Okay, different slices. You can see here, so this is lung part. Okay. What is this? Can you guess? This part? What is that? This is lungs on the two side, and in between lungs, what do you find? In between you have two lungs. What is that? This one. This part. This one. In between two lungs, we will keep on moving like this. We will find a bone. Bone backbone. Okay, that is what we are seeing here. And see here, there are so many white spots here, right? White spot. Okay. So the cancer nodule also will be looking like that one. Okay. So out of these many white spots, which is cancerous nodule, which is not cancerous nodule. Okay. The radiologist must go through it. Okay. So in this, we have got around in this CT scan, we have got around 300 slices. Okay. So 300 slices. Actually, it is a low dose radiation CT scan. So in the high dose radiation CT scan, what happens? Something around 700 to 800 slices. Okay, it is very common. Okay. So in such case, if there is a cancerous nodule or not, if you want to see, okay, just imagine the burden of radiologist here. Okay, he must go through every single slice like this. He must go to next slice, next slice, next slice like this. Okay, one by one slices he must go through. Okay, and through every slices it will take him for him it will take around 15 to 30 seconds. Okay, to check and tell whether there is a nodule or not. So around 700 slices per patient. Okay, and for every slice it will take around 30 seconds to check and tell whether there is a cancerous nodule or not. Okay, just imagine how much time it will consume. Okay, 30 seconds into so half minute into 700. Okay, or something around 350 minutes. Means around 6 hours. Okay, human beings can't sit for 6 hours continuously. Okay, 3 hours he will work, okay, then 1 hour gap maybe he will give, then the next 3 hours he will work. Okay, maybe per day he will finish one CT scan. Okay, so when thousands of patients will be coming to hospital, right? So when we reply back, okay, here is the place where the engineers are required. Okay? Doctors alone can't do all these things. Okay? So this is the CT scan. This is how we will if you cut the slices, okay, from here to here, this is how you will see each slice. Now you can see we are moving towards the top. Okay. Okay, you can see the shoulder bone, all that here. Okay. Here, left, right. and you are interested in the heart. There is somewhere here. This is the heart. So somewhere here, so we are reviewing. So somewhere you find heart here. Now this is the view that you will get when you travel from here to here. Okay, now when you travel from here, this place is also not possible, right? Slicing like this. That is also the review. We will go there. So if it is if our lungs are cut, the slices are cut in this fashion, in this all these angles. So we call it as sagittal, not sagittal, coronal slicing. Now this type of slicing is called as axial slicing. This is coronal slicing. This is sagittal slicing. So coronal slicing is it is cut like this. So it is cut like this. Sagittal slicing is it is cut like this. Axial slicing is it is cut like this. All the 3D. So if you are interested in this green area, that is coronal beam, what you must do, you can go for it is green, right? So go for green only. Okay, I can go through every slice like this. Okay, this is the rib cage, right? The bone is seen there. See, the brighter the any pixel here, it is more bright. What does that indicate? It indicates it's a solid part. Okay, bone it will appear as a solid part here. Okay, and that which is smooth, transparent. Okay, they all appear like that. So our lungs, no bones is there inside the lungs. Okay, it's all tissue, soft tissue. Okay, that's why it will appear like this. You can see so many white spots here. Among them you must go and see, okay, which is a nodule, which is not a nodule, okay, and it is a hideous stuff. Now, being engineers, okay, it will be possible for us to develop some machine learning tools which will tell us, okay, where exactly nodules are. I tell you, being engineers means when I tell, I am not talking only about computer science engineers. Okay, there are so many people in IIT Chennai, IIT Madras, some other places who are mechanical background, okay, and who are doing lot of research in this area. So it is welcome for us. So some part, some mathematics is important for us, okay, and some common. So yeah, what is our first task? Say for example, our software, the software that we are going to build, the machine learning system that we are going to build, say it has detected a nodule. Okay. Now how will you tell where that nodule is? To the doctor. Okay. So for that purpose, what must happen? First we must locating where the nodule is. Specifying that. That is very important. Okay. So given a lung CT scan like this, there is what is called as lung lobe segmentation. See, our lung, it is made up of 5 parts. Do you know that? Okay. So it is like God has created in such a way that on this side, right side, okay, there are 3 balloons. Got it? This is not a single balloon. This is not a single balloon. The moment we inspire, this balloon will expand. This balloon will expand. It is not like that. Okay. The moment we inspire, there are 3 balloons here which will expand. Okay. And there are 2 balloons here. Okay. This is called as the left upper lung. Okay. The lower part is called as left lower lung. On similarly side, right upper lung, right middle lung, right lower lung. So your job, being an engineer, if your system detects there is a nodule, its first job is to tell in which of these lobes, okay, left upper lobe, left lower lobe, right upper lobe, right middle lobe, right lower lobe. Okay, in which of these lobes is nodule is there? That is what you must first tell. Okay. So for that, segmentation of these lung lobes, okay, must happen. I am not going to show you that software which will take this CT as input and give me the different lobes as output. I am not going to show software. Okay, I will just tell you how to design a machine learning software in order to accomplish this task. So given this CT scan, lung CT scan, we get the output like this. you saw this? I will enlarge it. The top left screen, diagonally, I will enlarge it. So what does this mean? See, in this slice, this green part it belongs to right upper lung. This yellow part belongs to right middle lobe. Okay. This belongs to right lower lobe. This belongs to left upper lung, left lower lung. Okay. So slice by slice we will keep on varying like this. Okay. This area also varies. Okay. See, in this particular slice you will see only right lower lobe. See the lowest part. This corresponds to right lower lobe. Now, if I disable the CT scan, you will see this. So, given the CT scan, what is that? Given this CT scan, if we get this, okay, if we get this, we call it as lung lobe segmentation. So, what has it done? The software, what has it done? Given this CT scan, okay, it rejected all these parts. Okay, this both part it rejected, this heart part it rejected, all that it rejected. It took only the lung part, and in that lung part it identified which of these cells, whether this cell belongs to right upper lobe, lower lobe, middle lobe, all that. It has got that intelligence. It has got that intelligence, to tell which is what. Okay, see here. I will reduce the transparency of this. Okay, now you can see. Okay, these are the different groups. Now, how will you train a machine learning model such that given this as the input, it will give us the low output. How will you train? So, you may be knowing many of you might not be still exposed to machine learning. In machine learning, what happens? During the training phase, the CT scan is given, and at each point, what must be the output? That also is prepared. So, it is possible to prepare this data set. So what we must do is go to segment editor. Okay. So from this CT scan we want 5 different lobes. Okay. So that is right upper lobe, lower lobe, middle lobe, left upper lobe, left lower lobe. Okay. So what we do? We will add 5 segments. Okay. 5 segments like this. Then what we can do? Now, can you see a line here? When I show you like this, can you see a line here? There is a line going here. Can you see that? Is it visible? What is that line? It is nothing but I told you it is left lung part. Okay, part of the left lung. Left lung has got 2 parts: left upper lobe, left lower lobe. So left upper lobe is packed in a balloon, left lower lobe is packed in a balloon. In between, there will be a fissure line, we call it as. Right? So if I, for example, if I put one balloon above one more balloon, at the point of intersection of the 2 balloons, you will see a fine line, right? A very particular. That is what it is. Okay. Now, given this CT scan, I must train the machine learning model. But how will you train? So first you must show the machine learning model. Look, this is the CT scan, and in this part is left upper lung, this part is left lower lung. I must tell it. So what is machine learning system? It is just like a child. Okay. How will you teach to a child this is crow, this is parrot? How will you teach? You must take one crow, show the child this is crow. You must take one parrot, show that to the child, and you must tell this is parrot. Right? Like that. Okay, just like that in machine learning system also. Machine learning, any machine learning model initially is like a small child. You must tell what is left upper limb, what is left lower limb. Okay. So what we will do is we must tell here this we know it is left upper limb, this we know it is left lower limb. We must tell that to our machine learning model. How will you tell it? Okay. It is like this. We will paint with brown color this part. This part we will color it with blue color. Okay. So blue color is left upper limb, brown color is left lower limb. Okay. How will you paint? There are tools here. What you can do is just click a brown part and go for this paint option. Okay. Then what you can do is you can paint it like this. You can reduce the size of this paintbrush if you want to do delicate painting. If you want to finish task fast, you can increase the size of the brush. Okay. Now shift and right like this here. You can finish the task fast. Okay. See, this much got painted brown. Okay. Then there are some minute details. So you can reduce the diameter of this brush. Okay, then you can paint it delicately like this. You can fill the gaps. Don't leave gaps anywhere. Okay. I am teaching the machine learning model. Okay, by painting it in brown. Remember, this is left lower limb. So the upper part, I must tell it this is left upper limb. So what I will do, I will go and click at the blue segment here. Then what I will do, I will increase the size of my brush. Like this, then I will paint it. It is getting painted in blue. Entirely not painted. This is we have done it for just one slide. Still 300 more slices are there. Okay. You must go to the next part here. Okay. Then once again paint there. Okay. This process you must continue to keep on doing. Okay. It is a tedious task. So if you want to train a system, a machine learning system, which will okay, which will given these CT scan inputs give us okay, low outputs, low outputs. Okay, if you want to machine learning system, what you must do, you must take around 300 such CT scans. We have got only one CT scan. Okay, only one CT scan module. Such CT scan modules around 300 you must take. And in each CT scan you must tell the machine learning model, look, this is the left upper lung, this is left upper lower lung. Okay, similarly, right upper lung, right lower lung, right middle lung. Okay, they also must be painted in different colors. Okay, every scan you must go and paint. Okay, actually, if you have got a pulmonologist, if you have got a radiologist with you, if you have got a surgeon with you, okay, it is ideal situation. For paintings, because sometimes you will be not knowing which is the left lower lung, right upper lung. For example, if you move to the right lung, see here, do you see any line here? Okay, you can see one line here. Okay, one line here, one line here. Okay, so here upper part it is right upper lung. Somewhere here right middle lung is there, here right lower lung is there. Okay, you can see that line there. As I move the slicer, see you can see it clearly. Here is one line, here is one line, here is one line. This is right upper line, right lower line, sorry, right middle line, this is right lower line. Okay, so it is not clear sometimes. So here it is clear. You can see this line here, one line here, one line there, one line there. Sometimes it is not clear. At that time, there will be a confusion. If you do wrong painting there, okay, you will be wrongly painting machine learning system. Tell you that this is right upper line. You get confused and it will be wrong output. Ultimately, what happens? Once you detect the nodule, you will be wrongly specifying. If it is really present in RML, you will be telling it is present in RUL. So that must not happen. Search and unnecessarily, he will search in right upper line and he will see no nodules there. Actually, nodule will be in RML. Okay, all that must not happen. So under such circumstances, when you don't know correctly, you need the help of pulmonologists, radiologists, who have seen lot of CT scans for many years and who can identify clearly which is what, okay, which is right upper line, all that. So this is the one part of it. Now, once our system detects where a nodule is there, okay, it can tell in which part of the lung, whether it is present in RML, RUL, RLL, where it is present, we can tell. Once we get this lobe segmentation, okay, once we divide this CT scan into different lobes. Before that, question arises. Okay, how will you identify nodules? Okay, how will you train the machine learning model? Okay, for nodule detection. Given a CT scan, where the nodule is present, how will you train the model? Okay, you will see that. So how will the data set there? I am loading a new data set here. There are two things here. This is the CT scan. A CT scan volume of the lung. You can see here. So how many slices are there here? If you want to see, you can see that. See, you will get it here. This number here. It is indicating zero slice. When I take it to the right end, the last slice, you can see here it is 660. Okay, so for this patient 660 slices. Okay, were taken. Now I want to train a model such that what it will do, given a CT scan like this, it must tell me where the nodule is. Here also it is a machine learning model. I must speak that model. I must give it a CT scan. Then I must tell it, look, here is the nodule. One CT scan I must take. I must tell it, look, here is the nodule. If there are more than one nodule, I must tell here, there nodules are there. I must take one more CT scan. Where nodules are there, manually I must identify. Okay. Then I must tell it, here are the nodules. Like this for around 300 different data sets. For 300 different CT scans. Okay, when I do this to the machine learning model, okay, through going through iterations of training, you will understand, okay, it will learn, okay, to identify where the nodule is. Okay. Now, how to tell the machine learning model, here is the nodule. Okay, I will show you here. So, this is the CT scan volume. You can see here, all the 660 CT scans are here. I will disable this. Okay, I will close the display of this. Now, here, this is the dark screen that you are seeing. Okay, it is not actually a dark screen. 660 slices are there. Okay. Here I am moving like this. So do you see anything here? Did you see anything abnormal? Is it entirely dark? What did you see? See here, observe here. Did you see that? So what is it saying? It is saying at the minus 120th slice there is a nodule. Okay. So in the CT scan we go to -125. See this? You can see this? It was talking about this module. Okay, I will stop displaying it. Okay, you saw that? Okay, so like this is how we will say where the module is. Okay, so this is the CT scan. Okay, this is the we call it as variable volume. Nothing but this is CT scan which tells where the module is. Okay, this one. So in this, sometimes in the CT scan more than one module is there, 3, 4, 5. Okay, at that time wherever the module is, you put a white mark there. Okay, just like this. Okay. So this is the story of one CT scan. Around 300 such CT scans. Okay, you must prepare. Okay, then you can train the model. Once you prepare the data set, okay, training the model is very easy. There are so many machine learning models. Once you come in the world of machine learning, you will come to know that. Okay. Fine. So this data set, this will tell us where the using this data set we can train a model which will learn to identify where the module is. Then we have one more model. Given a CT scan, it will tell okay which are the in this given CT scan which belong to right upper lung, lower lung, okay, all that. Okay. So using that we can specify which low it is the module. Fine. Once the module is detected, the doctor will be interested in knowing what is the volume of that module. Okay. How much it is? 50 cm cube, 11 cube. Whether it is a very small module, 5 mm cube, or whether it's a big module, okay, 300 mm cube. Okay. How will you identify that? None of them is possible. Okay. So what they do is the module detection model, it will identify okay, where the module is. For identifying where the module is, okay, from the CT scanning machine, at what distance the module is there, that also you must tell, right? Then only doctor can go and operate and see. Correct? So all these images, they are not just like that. There is distance information also involved in it. I will give you the distance information of this data. Go to this volume, click it here, select the volume. Okay, you will get one this data set. And volume information is here. You can see here. Or you can see here. There are 661 slices. Okay. And image spacing. It is this much. What is the meaning of this much? See, once the body is the lung is cut here. Okay, one slice. After what more distance the next slice is cut. That is what this will tell. 0.5 mm. Okay, so thin slices they have been cut. Okay, so first lung they have cut here slice. Okay, the next slice they have gone 0.5 mm just below. Okay, why they go so resolutely? They could have left 2.5 mm and then go on and cut it there. The reason is they don't want to miss even the smallest nodule. That's why they have cut it resolutely. And in the y direction, how they have cut? For every 0.6 mm, they have cut it. That's the meaning of it. Here also 0.6 mm. For every 0.6 mm, they have cut a slice. That is the meaning of it. Okay. So one, we call it as this is a volume, right? If it is 2 dimension, we call it as a pixel. This is 3 dimension. We call it as a voxel. So one voxel here means it is 0.6 mm width, 0.6 mm height, 0.6 around 0.5 mm width. Now using that information, we can with this volume force we can where exactly inside the lung this nodule is located. Not just that much. Okay, so it will tell us where exactly that nodule is there. That much is not enough for us, for a clinician, for a doctor is not enough. What is the volume of that cancerous nodule? How big it has become now? Whether it is small or big. So for that, we require further data. Okay? Further also we use machine learning model. Okay? Given a small area, given a small volume around that nodule. Okay? So what part of that volume is model. How the data set is prepared for that? We'll see. Just 10 minutes. So I will show you some data set, which you will see here. One data set is here. Okay. So you can see here, this is not entire CT scan. This is not entire CT scan. Okay. This is just one small volume. Okay. However, this is the full lung. We have gone to a position where there is a one module, and around that we have small cut. We have cut a small cuboid. Okay, and that is now. In this, can you tell me which part is cancerous, which part is not cancerous? See here, so many things are white here, right? All of them are cancerous. So we have cut a small volume around the cancerous nodule. And what happens? Cancerous nodule, when it is growing, or if it must grow, it wants some food materials, nourishment. So what it will do? It will start sucking that nourishment from the surrounding blood vessels. So as it keeps on growing, it will have developed a nice network of pipes around it, which will bring blood to it. You can see that here. See, this is the cancerous nodule at the center. Okay, and you can see the blood supply coming in and out, right? Okay. So you can see this pipe is coming here, carrying blood. This pipe is coming here, carrying blood. Okay. So given a area like this, given a volume like this, we need a machine learning system which will tell what part of this is nodule, cancer nodule. Okay. So the doctor will ask us, once we detect the cancer nodule, the doctor will ask us, what is the volume of this nodule? At that time we can't take a blood vessels volume also, add it and tell him this is the volume of the cancer nodule. It is not allowed. So we must identify here using some color. We must identify what part is nodule, what part is not nodule. So how we do that? We will see. For this also we must prepare one data set. Given a CT scan like this, of a volume around the nodule. Given a CT scan like this, how to train out machine learning system telling this is nodule, this is not nodule. In this volume, what part is nodule, what part is not nodule? How will you inform it? How will you inform the machine learning system? Okay, it is like this. Go to segment editor. Then add one segment. You want only one color here. Okay, so I identify whether it is nodule or not nodule. Okay. Then what you do? Go for thresholding. Okay. So all these radiologists know. Cancerous nodules, their intensity. Okay. So intensity here you see in ordinary image, how is the intensity measured? Pixels, right? 0 to 255. Here it is not like that. It varies from minus 5000 Hounsfield units, not pixels here. Okay, Hounsfield units. Minus 5000 Hounsfield units to around 20,000 Hounsfield units. Okay. And cancerous nodules, their intensity it ranges from minus around 467 Hounsfield units to around 20,000 Hounsfield units. So what we will do, we will threshold it. Threshold means I am taking this, then I am telling it, okay, threshold it in such a way that, okay, so minus 467, okay, something around that, to find it. Okay, you can see now, when I did this, see here, when I am varying this, see it is like this. When I did it to minus 467, what has happened? This slicer tool, what it has done, all those regions which are within the cancerous range, okay, it has highlighted. Okay. Now what you can do? Apply apply, go to data. If I got a segment engineer, what you do? You can create a closed surface representation. So what will happen? You will get this. Okay. You can see here in the center there is a cancerous nodule. Okay. At the center cancerous nodule is there, and various pipes are going away from it. It is nothing but a blood vessel. Okay. So we must cut all that. Okay. After that, we have got two with us. Go to segment indicator. Take scissors. Okay, just cut it like this. Unwanted nodule part. Sorry, blood vessel part. Okay, now it looks more. Here some unwanted things are there. Can you go like this? Here when I cut this, okay, the shape of this nodule also is changing. Remove this blood vessel. See here, it's got cut. So this is how we prepare the data set. So in this volume, this is the part that is corresponds to the nodule. Rest all is cut. So like this, we can show the machine learning model. This is okay. This part is the correspond to this one. This part, okay. This part doesn't correspond to this one. So around 300 such cities, small city volumes, you must prepare them. Okay, and you will give it to the machine learning model. It will learn. Okay, to identify given a volume, okay, containing nodule, okay, nodules plus blood vessel, okay, it will learn how to identify what part of this nodule, what part of this blood vessel. Okay. So once it comes to know this part is the blood vessel, sorry, this part is nodule, it will go there. It knows okay, one voxel means how much volume it is. That into number of voxels that are inside that, okay, inside that segmentation. Okay, it will calculate the volume. So the doctor can get exact location, what is the volume of it, all that information. I think we can stop it here. Thank you, okay, all of you for patient listening. Okay, you understood or not, I don't know. Okay, but being engineers, it is our job to be contributed to the society, right? Something, okay, coming here, doing something and doing that must never happen. Okay. So at the end of the day, when you go to sleep, you must feel that I have done something useful. Okay, I have tried my best. That's something you are feeling. So there is no barricade here which will prevent you. Okay. So at any stage of your life, you can start research in this area. Okay, whether your marks is low, whether your marks is high, don't bother about it. Okay, there are so many opportunities throughout the in India itself. So many opportunities are there. So many research labs are there. Okay. So you can follow your dreams. You are still young. Okay. It is up to you how to follow your dreams. Okay. Go and meet some researchers, how they landed up there, ask them, they will easily tell you how they got into there. Okay. So be some, nobody is going towards machine learning these days. You can see that among students also. Okay. So try to get into this. It is very interesting. Okay. Being engineers, you will be feeling the satisfaction. Okay. Yeah, we will stop it. It's always 11:30.